Welcome to BeeGraphy. In this 10th tutorial, we are going to look at estimation. We are going to see how to estimate the quantities, and subsequently we'll see how to get the cost of all the items and geometries that we are creating. So we'll look at our old scripts, the things that you are already familiar with if you've been following this series. One is the attractor logic, where we've got all these towers or blocks. And then we've got the twisting tower with slabs, skin of the building, and the balcony wall. And finally, we've got the dynamic facade, in which we've got panels and the frame. So in this, let's say these are made with stainless steel box sections. Let's say they are in centimeters. The dimension of the square is 8 by 8 centimeters. And for this to stand, let's say the thickness is 1 centimeter and they are hollow. What we are going to do is we are going to extract all the lengths of our towers, because we need the box section's length, and then we are going to cut it off and then place it, weld it wherever we want it to. So we'll search for extrusion. So extrude curve, it is moving in the Z direction and the output is this. Factor is the amount of height you want, amount of extrusion you want to give to these towers. So since we are considering all of this to be in centimeters, this is 53 centimeter, 57, 56, 53, and it is neatly branched in 8 branches. Each branch has got 8 items. So there is basically the grid is 8 by 8, so there are 64 towers. So each of the length corresponds to their subsequent respective towers. But we don't need the data to be structured, so we are simply going to flatten it, and then we are going to add all of them. So now I have flattened it. So all the numbers are now in just one single list, and we are going to do mass addition. Mass addition simply adds the list of numbers you give it. If I did not flatten the tree, then this is what you will get. You will get 8 branches, because now it is simply adding maybe each row of lengths and giving me 8 outcomes. We don't want that. We want to flatten it and just simply get the final outcome. And part mass is simply sequentially adding each number. So just like when we do dimensioning in CAD for architects, we've got a continuous dimension which will break everything and give you dimensions, and then there is a running dimension which will give you dimension from a baseline. So baseline dimensioning is there. This is what it does. It simply adds on, and then the last item will have added all the 64 items and give us 2660, which is the entire lengths combined. To check it that it is working live, I am going to, let's say, move our attractor point somewhere else, somewhere here, and then see how the number has changed. It's 2762 now. Previously it was 2660. So no matter the design, it will quickly calculate and give you the entire length of steel sections needed. Now we can use ChatGPT to get a rough idea. So give us the cost of steel hollow section, 8 centimeter by 8 centimeter in dimension, 1 centimeter thick, in dollars. It's gonna give us the rates, which is $1.5 to $3 per kilogram because steel, metal, it is sold by tons. So it will do some maths for us, and it has given us 0.04 USD to 0.1 USD per meter. That's a big range, but of course we'll be knowing it when we are in the market. Give us the rate per centimeter running length, and this is excluding, of course, of welding cost and labor cost and everything else. But I'm just giving you an idea of how you can work with whatever data you have and combine it with your script. So the cost for centimeter per centimeter is 0.0044 USD per centimeter, 0.0044. So I'm going to multiply this with 0.0044 and see what we get. Just 12 centimeter. Okay. Interesting, but that's what ChatGPT said. But you understand how we are calculating things. The other way would be, let's say this entire thing are solid sections, they are not hollow. We are going to get the volume of all these towers. The volume we are going to get from this component, solid volume, and I'm going to take cap node and put it here. As you can see, this is pink. This is pink, so it means the data is solid. Whereas if we directly take from extrude curve, it will only be surfaces and it will show me an error and this will turn red. Right, so take it from cap, solid volume, and I'm going to get same thing, 64 items. And don't worry about the negative sign. Calculating volumes does give us negative values, but that's fine. We can use opposite to convert it, and then I'm going to flatten and then mass addition. Panel. So we have 298,330 centimeter cube of material. Centimeter cube. So centimeter cube to meter cube. So I'm going to convert it to meter cube. Conversion factor. It'll be a big number. So 0.50 and then 1, right? So or simply I can divide it by 1 million. 1, 2, 3. And we will get around 0.3 meter cube, and density of SS is 7850, or we could have simply used 7.93 gram per meter cube, but it's fine. We'll use 7850 kg per meter cube. So 7850 multiply by 7850. So this will be the amount in kgs if the entire thing is solid. And now what is the rate of SS per kg? So there are different grades of stainless steel and they vary according to that. So another thing that we can do is we can give that the option of selecting what grade of stainless steel you want and then get the estimate in the script itself. What I mean by that is you can add all the three values and put it in a select node. So the select node allows you to select an option and it will have its subsequent value related to it. So for example, we've got grade 304, grade SS. The value is 2.5 to 3.5. Let's take 2.5. And then we add one more and we type in 316, 3.5. 316 grade SS, which is $3.5 per kg. Now you can select any of them, 3.5 or 3.4, and it will give you an output that is related to that selection. Right, so 304 was 2.5. Now what is string? String is just, it is alphabets. It does not hold a value. You cannot do mathematical calculations using string. A number, data type number, is something that you can multiply, add. So 2 plus 2 is 4 if the 2 and 2 are numbers. But if they are strings, 2 is just text, a string. Then 2 plus 2 becomes 2, 2. 1 plus 3 becomes 1, 3. A plus B becomes AB. So it's something that is fundamentals in coding. You know, there are different types of data: string, integer, or the numbers that we have that are 1, 2, 3, 4, 5. Then there are decimals that are float or double, which is 1.5, 0.3. Then there is curves, surfaces, solid. All of these are data types. So string is a data type and it is giving out 2.5. So we need to convert this into a number. So we've got string to number component that will convert this string to a number. You see the panel has not changed even a bit, but you can see that the colors have changed. The string is purple, dark blue, and this is cyan or light blue color. Right, so now the string 2.5 has converted into 2.5 number. And if you give in A or B something, then it will show an error because that's not convertible to a number. It's a alphabet. All right, so we've got this 2.5 and we are going to multiply it with the kgs output. So I'm simply going to do multiplication. This, and finally we get $5,854 of yield. And if we take 316 grade, then it becomes $8,200 approximately. So this is some this is one way to calculate material and the cost of it. Then of course you can add contingencies. So we can multiply it by 1.1. to get 10% contingency, to consider the 10% contingency cost. And if you want to make it more user friendly, you can get a number slider. So you can say that this is the contingency percentage that you can put in. Let me rename it. The percentage. And this will be divided by 100, and then we are simply gonna add 1. Oops, sorry. Add 1 to it and put it here. So when we have 10% contingency, the panel is showing 9,000, and if you have 0% contingency cost, then it is 8196, just like before. So you can quickly adjust the contingency costs and select whatever material you like and change all the geometries, and you will quickly get which one costs more, which iteration or option costs more than the other one. So this was good. Let's move on to the dynamic facade, which is also simple. In this case, we'll be working with areas for our panels. Let's search where is our diamond panel, and this is the diamond that is going in offset curve and then curve to surface. So this is our main geometry. This is the main thing that is being rotated. So let's use this. Type in area. We can have curve area directly, but let's do surface area. Or if you want curve area, you can do it. Sorry. Curve area. Then you can use this one, and both of them should give the same thing. Let's check 2.6, 2.601. Of course, all the diamonds are of exact same dimensions, so we get exactly the same values. Let's use curve area, and then I'm going to do mass addition because it is already flattened. There is no grafting. You can see the thick wire. So we've got mass addition, and then we check the panel and we see the number. So this is 59.8 square units. So if it's in feet, let's say we need 60 square feet of the panels. And again, we can use ChatGPT for now to understand what's the rate. Tell square feet rate for steel sheets of 12 mm thickness. 12 mm is around this much, pretty thick. All right, so we've got two values, 17.4 and 26 USD per square feet. So let's take $20 per square feet, and we can actually leave that as empty space or a number, what do you call that? A range input, so that the user can actually select the rate themselves. But if you know the rates, then that's fine. So I'm going to put in 20 multiplication and then 20 sign. Wow, this is even quicker. So we've got $1,200 for the material if this is 12 mm thick, and we calculated through square feet rate, $20 per square feet. And with regards to the pipe, we've got cylindrical pipes. We can do the volume thing here as well. And the pipes are, there are two pipes, right? So we are going to first cap them, because right now they are hollow pipes. They're open on both sides. And even before capping, let me just merge the lists to get, oh nice, so we don't even need to flatten it. All these pipes are now in one list, and let me cap them, and then the capped one will go into solid volume, and here you can see 98 volumes, And you'll also see that all these are identical values, and then after a while all of these are identical values. That's because the diamond pipes, the framework for the diamond is exactly the same. All these lines are same, and all of these lines, all of these pipes are also of same length. I'm going to do mass addition, and you will get the final result, which is 6 units. So that will be, since we are working in feet, so this is 6.47 cubic feet. Cubic feet rate of SS. And again, we are considering solid sections. So let's just get a number. Would range from 500 to 1200. Let's take 600 and multiply it. Multiplied by 600. So this would this is how much it cost to make this frame. This just the material of this frame, which is 3,800. Expensive. Cool. And lastly, let's move on to the tower, which is much more in my domain. We've got the skin of the building, we've got these slabs, and we've got the balcony wall. Let's get a rough estimate for them. Rough, just a second. Yeah, we were working in meters. So rough square meter cost for skin of building in glass. Until it's calculating, let me just do some work here. So we've got 3 parts, right? Before the thickness, we've got extrude curve. So this is balcony, and this is slab material. There is side thickness, curve to surface. Awesome. So we can get the volume by simply getting the volume of this solid volume, and we can do mass addition to get the mass, the volume of all the slabs combined in cubic meter, which is huge, 7,900. Wow. This building is going to be expensive. All right, so this is 600 square meter inclusive of framing, glass cost, and installation. So 600 USD per square meter. Where is the building? Yeah. This was the slab. So it is 600 dollars per square meter. We've got let me see, loft surface. Let me just check if it is the correct one. Yeah, so when I'm selecting on the relay, it's giving me the entire skin. I'm going to do area, surface area. See, what do we get? Nice. I simply have to multiply it by 600. So this will be the cost for the glass part, the skin part of the building. Huge. It's $3.9 million. The building is also massive. So secondly, and I think the cost would go much more than this, because as you're going further up, it gets more and more difficult, and more specialized machinery is required. So let's go back to our slab that we were working with. we've got the volume of the slab. We have to just look at concretization of the slab. So give rough estimate of slab cost in cubic meter rate. So that will give us the cubic meter, and we've got our volume in cubic meter. So we are simply going to multiply it with the rate 200 to 350. That's a huge range. More specialized could range from this. Okay, so this is 125 to 190. So let's take 150 for now. Multiply it by 150. And we get 1,185,000, 1.2 million approximately for slabs. And this includes transportation costs, quantity, labor cost, everything. Interesting. I was expecting it to be a lot more, but nice. And then we've got balcony walls. Now we can either do by volume or by running feet or even by the surface area. All three methods are valid. Let's do by volume. Tell rate per cubic meter for balcony wall. Right. It's okay. So it includes even finishing, height of the wall. Concrete balcony wall is this much. Brick or block balcony is this much. Let's take $200. Where is our balcony? Wait, sorry, I was in the different script. So this one is the balcony material, and we've got side thickness, and it gives us the solid. Yes, perfect. So I'm going to take the volume of it and then mass addition and panel. Nice. Multiplied by, I was checking if it is branched or not. It is nice. One thing only. Also, we need to multiply it by a negative number. Let's do opposite. Anywhere you can put in the opposite after volume. It's fine. Finally, we get the cost for balconies, all the balconies. It's only $224,000, unlike the other ones. And finally, we've got mass addition again, and we are going to add all these costs together to get the final cost of the building without considering columns and so many more things, but you get the idea. And this one. I'm pressing shift so that the other wires don't get disconnected. And finally, we have $5,382,325 is what this building would cost. So yeah, I think this was informative, and this helps you understand the calculation aspect, and you can use it as per your requirement. Let's say you're creating a furniture, you want to know the entire amount of plywood required, the surface area, you can use it surface area to get it. and then multiply it by the rate to get the final cost of the material. Then you can also multiply it with certain things, like approximately you know that each ply is needing so much glue, maybe nails, etc., labor. You can multiply those factors and get the final cost. And the best part is it is completely parametric, which means you can change number of floors, you can change the floor height, and see how that changes your cost. So from 5 million, it went down to 3 million. Amazing stuff. So hope that helped and you enjoyed learning. So that's all for this tutorial. See you in the next one.